Komið þið sæl. Í þessum þætti ætla ég að fjalla vefinn techblog.com en sá vefur hefur tekið saman 7 myndbönd sem hægt að finna á YouTube svona tækninýjungar sem að koma til með að verða kannski möguleiki á árinu 2013. Nú, í 7. sæti hjá þeim þá það þrívíddarprentari sem að hægt að setja jafnvel verður komið inn á heimili kannski í lok þessa árs, ég veit það ekki. En við skulum kíkja á þetta myndband og sjá svona hvernig þessi prentari virkar.
I've been involved in the field of personal fabrication for 5 years now, and I've seen what an amazing impact that these tools can have, but I've also realized that these tools are just a fraction of what's possible.
When we were at the Media Lab at MIT, we had access to an amazing set of tools, 3D printing being one of the most important.
For designers and engineers like us, there was simply no solution if you want a high-resolution 3D printer at a low cost on your desk.
So we decided to build it ourselves.
I really cannot imagine where my research would be without 3D printers. I would really like to have a 3D printer at my desk. We don't currently have any of the existing low-cost machines because the part quality, resolution, and repeatability is nowhere where we need it to be.
In architecture and many design fields, the software tools have advanced pretty significantly, but there's been a gap between what you can actually design and what you can actually make. And I think the Formlabs printer provides an exciting opportunity to be able to design and then physically make quickly precise, complex geometry.
Formlabs changes the way people design things. They're going to be able to get really pro-quality 3D printed parts way cheaper, way faster than they've ever been able to do that before. Formlabs takes us a giant step closer to the engineer's dream, which is routine 3D printing, the way they'd print on paper.
To design a 3D printer that produces great parts every time, we've got to bring together a team of designers, engineers, and material scientists to make a tightly integrated product. If you can do that, you can fundamentally change 3D printing, and I think we've done exactly that.
Stereolithography is great. It's a tried and true process. It's been around for well over 25 years. It produces the best quality parts in the industry.
The way it works is pretty simple. A laser beam is drawn across the surface of a liquid plastic resin that hardens when exposed to a specific wavelength of light. After the layer is drawn, the build platform lifts and the process is repeated layer by layer until the part is finished.
We have a great user experience. We have powerful and easy-to-use software. We've built a reliable and beautifully designed printer, and we're developing materials which will enable our users to make amazing things. We've been working on the design of our product for over a year, and it's nearly complete. And so now it's time to start gearing up manufacturing so that we can get it into the hands of users everywhere. But to do that requires substantial resources.
The bottom line, designers are going to be able to make a lot more 3D printed parts. And I don't mean a few designers, I mean a few 100,000 designers, 1 million designers are going to have access to 3D printing in a way they didn't before Formlabs.
Imagine you have an incredible concept, and what we want to do is give you a great tool to make it real.
Nú, vefurinn Techblog setur í 7. sætið eitthvað sem heitir face cloning. Þetta einhvers konar hugbúnaður sem að Disney að búa til og það gerir það verkum að hreyfimyndir eða teiknimyndir eiga eftir að fá nýjan blæ hugsanlega í framtíðinni. Kíkjum á þetta.
We propose a complete process for designing, simulating, and fabricating synthetic skin for an animatronics character that faithfully mimics a given target subject and its expressions. The goal of our work is to automate this process, to increase the realism of the resulting character, and ultimately to create an animatronic face that closely resembles a given human subject. In order to accomplish this task, we capitalize on recent developments from 3 areas in computer graphics: facial performance capture, physics-based simulation, and fabrication-oriented material design. The process starts by capturing 3D facial expressions for a given target subject. This data provides information about the deformation behavior of skin. In addition, we also determine the operational range of the animatronic head, which consists of a set of skin attachment links actuated by motors. We then measure elastic properties for a collection of different materials used to manufacture synthetic soft tissue. Given all of these measurements, we employ physics-based simulation to predict the behavior of any soft tissue made from these materials, and our optimization process uses the simulation to determine the geometry along with the actuation parameters in order to best match the target expressions. We demonstrate this process by physically cloning a real human face onto an animatronics figure. We use a video camera array and current state-of-the-art performance capture techniques to reconstruct 3D facial geometry of a target subject. The result is a detailed, compatible mesh sequence with explicit temporal correspondence, allowing us to analyze the deformation of a face under various expressions down to the level of individual wrinkles. Our base material for the synthetic skin is silicone. In order to determine the material parameters for the skin simulator, we experimentally acquire force displacement samples of materials of different stiffness. We then optimize for the geometry and actuation parameters in order to best match the target expressions using a single optimization framework. Forward simulation allows us to accurately predict the deformed shape of a given synthetic skin and the resulting forces induced by the moving skin attachment links. Here, the optimization is converging to the best skin thickness for a forehead patch in order to produce a desired expression. After having optimized the ideal skin geometry, we create a mold for pouring the silicone. The mold consists of a core resembling the inner surface of the skin and 6 outer parts that can be removed for extracting the cured skin when it's complete. After mixing the silicone with the corresponding catalyst, it has a liquid consistency and can be poured directly into the mold. We use a pressurized gun to inject the silicone. Approximately 7 days of room temperature curing is required until it is ready to be used. We showcase our complete pipeline by physically cloning a human face for an animatronic figure.
Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out? Do or do not. There is no try. Why are you trying so hard to fit in when you were born to stand out?
In this work, we have presented a complete process for designing, simulating, and fabricating synthetic skin for an animatronics character that faithfully mimics a given target subject and its expressions.
Nú í fjórða sæti á þessum vef þá það þrívítar LCD-skjár sem notast við 360 kerfið eða 360 rið sem gerir það verkum þetta verður mikil skerpa og framúrskarandi myndgæði. Þannig að þá verða þrívítargleraugun væntanlega óþörf.
So we've all seen holograms in museums and gift shops. They look beautiful, but we still can't go to the electronics store and buy that holographic television. So the question is, why hasn't that happened yet? Well, one of the main reasons is that a holographic television will require pixels many times smaller than what we can manufacture even for our best mobile phones today. And so what we're trying to do in our laboratory at MIT is develop a 3D display technology that uses today's dominant display technology, which is liquid crystal panels, in a way that can create a beautiful 3D scene like a hologram.
As we move from two-dimensional displays to hyper-realistic, multi-dimensional displays for 3D, for light fields, for multispectral and lighting-aware displays, the bandwidth requirements move from gigabytes per second to terabytes per second. But by using compressive displays, we can exploit compression not just in software, but also in optics, and bring those bandwidth requirements within manageable limits.
So what's our secret sauce? Well, if you look at the natural 3D world, say a white wall, it turns out as you move your head back and forth, that wall doesn't really change. And so what we do is we take compression algorithms, like you'd have in your digital camera on our DVD or Blu-ray. We look at the world, we identify these redundancies, and as a result, we can actually use liquid crystal panels with those large pixels to create beautiful 3D scenes that almost reach the quality of holograms today.
Here, the prototype is assembled in the directional backlight configuration. The front LCD layer sits atop a directional backlight, which is obscured while assembled. The LCD driver electronics are mounted with the panel on an aluminum plate. The plate is accurately positioned using a rail and clip system. From the side, the location of the directional backlight, composed of a uniform backlight, LCD, and lenses, can be more clearly seen behind the front LCD. Because of the close layer spacing allowed by the directional backlight design, our two-layer prototype has retained the thin form factor of an unmodified LCD panel. We now compare to the three-layer tensor display prototype. In this configuration, 3 LCD layers are illuminated by a uniform backlight. We choose a larger layer spacing to demonstrate the flexibility of the tensor framework and to avoid moire interference without the need for custom holographic diffusers. Displayed 3D images are perceived without any flickering, but when filmed with a high-speed camera, the temporally varying tensor decompositions are clearly visible for each of the 3 layers.
So I think with new research, you always want to ask, why is this relevant now? And for us, we're taking advantage of 2 big trends in display hardware and graphics hardware. So the first is really high-speed display panels. And this lets us show a bunch of frames that your eye adds up together as a single coherent image. The other trend we're taking advantage of is really high-speed graphics hardware. So the chips that go into your laptop, your phone, or your desktop PC have become so fast in the last 5 years that we can solve a whole complex computational problem in the time it takes to show just 1 frame of video. And this has enabled a whole new way of thinking about 3D display.
Læriðu á tölvu á einfaldan hátt. Mikið úrval myndbandanámskeiða á vefnum netkennsla.is, Photoshop, Google Picasa, ljósmyndanámskeið, Garmin leiðsögutæki og margt fleira. Netkennsla.is. Langar þig að læra meira á Windows stýrikerfið? Það komið nýtt kennsluefni á vefinn okkar, netkennsla.is.
Bombay samloka með salat eða franskum tandúri marineraðar kjúklingalundir borna fram í speltbrauði með mango tjötni, fersku grænmeti og rætu. Aðeins 570 kaloríur, 1890 krónur. Texasborgarar, Grandagarði 11.
Ultraglós bílabúnið hið fullkomna bón á bíla sem fara reglulega í bílaþvottastöðvar. Því Ultraglós þolir tjöruþvott og sterkustu þvottaefni. Magnað bón í vetrarakstrinum. Ultraglós fæst í verslunum Bíkó land allt.
Þú ert að horfa á INN, Íslands nýjasta nýtt.
Nú í þriðja sæti að þá það Google bílinn. Nú Google semst að pröfukeyra sjálfstýrðan bíl, þannig að þá verður alsjálfvirkur bíl sem að getur keyrt sjálfur, þannig að þú situr ekki undir stýri. Nú, bíllinn gengur undir nafninu Óskar og við skulum kíkja á þetta myndband þar sem við fáum að sjá svona hvernig bíllinn virkar. En það ríkir gríðarlega mikið leynd yfir innvolsun í bílnum, þannig að við fáum nú ekki að sjá inn í hann, en við sjáum hann í hvernig hann keyrir
This is Oscar. This is Google's new self-driving car. It's been in development for at least 4 years, and this is the prototype for a technology that Google is here in Washington to display. They hope that it's going to be able to help, maybe elderly people, blind people get from place to place without having to actually rely on another driver. We're going to show you some features of this car. We're not allowed to actually film some of the technology inside it because it's proprietary technology, and Google doesn't necessarily want us to give some of that away. There is a laptop here which they are using just in the development of the car to kind of sense where people are, where other vehicles are. It kind of allows them to program that into the software of the vehicle. Let's come over here. We'll show you a couple of features of this car. These are all sensors. These are radars on the side and in the front here. Okay, and there's one on the other side here. But what we're going to also show you is a camera, which obviously is a crucial part of this vehicle. It anticipates what other cars are doing. All of this information is gathered into the camera, into the radar, into this laser scanner on the top here, and it's processed into a computer. The computer then commands the car what to do, to stop, to turn, to do other things. And it all happens dozens of times a second. That information is processed through. So the computer is in the car. This stuff is mounted on the car. It all processes through the computer. The computer gives the car the commands on what to do. We took a test drive just a couple of moments ago where we were, just going around the block here with the Google engineers without driving, and we were able to get some still pictures from inside the car to show that. We were out driving this thing. A garbage truck kind of moved across the road in front of us, and the car on its own kind of came to an abrupt stop, and it just was doing that the entire time we were in it. So a lot of kind of really cool and very strange sensations when you're moving around in this car. He's got no hands on the vehicle. Now, this has stopped automatically, and guys, why did it stop automatically? Do we know? There was a taxi who was kind of cutting us off there a little bit. A lot of questions about this car because, there are questions about, well, is it going to be able to anticipate pedestrian behavior in addition to car behavior? Well, Google says they're developing a software that does anticipate pedestrian behavior and kind of is able to make the car abruptly adjust to something that a pedestrian might do, which could be very, very unpredictable. And there are also questions about possible hacking of some of this technology. Hackers have been able to hack other technology in other cars, like anti-lock brakes, on occasion. Google says that basically they have engineers at Google who are used to their technology being attacked all the time, so they are doing everything they can to minimize the prospect of hacking of this vehicle. But a very exciting new piece of technology that Google is developing, the self-driving car, emphasizing too that Google has no interest, they say, in actually making cars. They're developing this technology so that car companies can put that into their vehicles. Brian Todd, CNN, Washington.
Nú, í annarsæti setur þessi ágætu vefur techblog.com Google glerugu. Þetta eru glerugu sem hægt að setja upp og sem þá hágæða hátíða myndavél. Þar sem við getum tekið upp einhvers konar atburð og sett hann á rauntíma yfir á netið. Skulum kíkja hérna á áhugaverðan fyrirlestur þar sem nokkrir aðilar henda sig út fallhlíf, lenda á ráðstefnunni og fara síðan á reiðhjólum inn í ráðstefnuna með glerugun.
This can go wrong in about 500 different ways. So tell me now, who wants to see a demo of glass? So we've been really excited to test it for a few months. The unit I actually really want to show you, I lent to a friend, and he's going to be here momentarily. My friend's JT. He does a lot of skiing, base jumping, wingsuiting, all sorts of crazy things. And he's actually pretty close by. He's just about a mile overhead right now with his buddies. They have a few glass units. If you guys can maybe afford to wait that couple minutes, maybe they'll bring them down. All right. They've got to get to the right place so they can hit the roof. I'm going to take a few pictures to record this for posterity. And they're off. Yeah. All right, and they're flying. Look at that. Look at that. You can see Moscone right below there. Live hangout through Google Glass. We've got 4 skydivers. And they're under canopy. Chutes are open. Woohoo. Okay, where's Vic? Vic, hey look, this is a hangout on air. It's a little bit tricky landing on a building, as you might imagine. I don't know if you've ever tried this kind of thing before. You can see all their perspectives now. They're going to have to line up one after another to get down to the roof here. It's a little bit of, it's a pretty big roof actually, which is great for their landing. All right. Down. Yeah. Hey folks, thank you. Woohoo. Hey, so the roof is a little bit big there, so it would take a while to run down the length of it. So we got actually a few bikers up there for this eventuality. We got them wearing glass too, and there's our little package. Let's see if we can get it here in a hurry. All right, here we go. First person view of glass. Here are the bikers. Yeah, woohoo! Here they come down. And, you know, there's only one good way down the side of a building.
Have fun.
It's pretty high up there if you haven't been up there before. Don't try this at home, kids. These are trained professionals.
All right, now we got to get down there. Want to unplug me?
All right, here they're going. Oh, wait, that one. Wait, whoa, whoa. No, we're on the third. Okay. Close call. Sorry about that. So this is pretty wild. I've never seen that perspective before. And
the delivery.
Yeah, I'm really looking forward to this. All right. We got a couple more bikes. It's a little bit of a long way. I apologize. Don't run anybody over. Oh. All right. Please stay in your seats, folks. Don't get into the aisles. Please keep the aisles clear. Here they come up. Yeah! Woo!
Við höfum verið að skoða vefinn techblog.com þar sem að þeir eru að diskutera hvaða nýjungar verða áhugaverðar á árinu 2013 og í fyrsta sæti Leap Motion. Það að segja við erum að notast við dag spjaldtölvur og síma þar sem við erum með snertiskjá. En hvernig verður veruleikinn þegar við notum ekki lengur snertiskjá að tækin eru farin að nema hreyfingarnar okkar? Kíkjum á þetta. Fyrsta sætið. komið að lokum þessa þáttar. Ég vona að þetta hafi verið áhugavert og ég vona að hafi haft gaman af þessu techblog.com. Því miður komst ég ekki verið að texta þetta. En myndirnar tala sínu máli. Nú hægt að nálgast þáttinn á intv.is og síðan hægt að senda fyrirspurnar á olafur@netkensla.is. Nú fyrir þá sem að vilja koma efni í þáttinn, endilega sendið mig fyrirspurn eða hringi bara í mig og hægt að finna þá allar upplýsingar á netkensla.is. Takk fyrir í kvöld, verið sæl.